traffic signals, and then signs and maps, right? Motor devices. Bandwidth you can think about that is the number of lanes. Okay. If you have a car, so what will happen to car reaching the road? How you are controlling? How where to stop, how to go, which side it has to go, which map has to follow. That and all is nothing but the network devices. And the same car, if you are traveling on the single lane or double lane, or if you are going on the bigger road and all, will be something different. This is another one example we can call it. The bandwidth measurement you may have seen in your books. That's BPS, kbps, mbps, then gbps, terabit, etc. and all will be transferred. Okay. It is a kind of equivalence. You have studied here. I don't want to go this much deep on this. Just overview I am doing. Then bandwidth limitation. This is a bandwidth limitation, and let's say this 10 to 100 Mbps, that is a 185 meter. 10 to 100 Mbps, the bandwidth is there, means that's maximum physical distance will be the 500 meters. And then 10 Mbps, 100 meters, physical distance should be there. Otherwise, the data will be dropped. That's the maximum distance we can control. If you are transferring the 10 Mbps, it should be the 100 meters cable should be there. Okay. It's a kind of different media is there, you can check it out. Okay. And then if it is 1 Gbps, you can make it a physical distance that has 3000 meters. Okay. Wireless can be 11 Mbps for the 100 meters. So after that you will not get the signals. It's a kind of media how it is working. Using the layer to analyze the problem, what is coming, what is flowing and what object flow, what routes cover flow, where does the flow occur. That is what we can go to here. This is a OSI layer. This is a commonly IT industries are following for this. How the data is transferred from the source to destination is a physical medium. Let's say the data is transferred from the upper layer to the physical layer, and then using the physical medium, it is transferred to your destination. Right? This is where the data is transferred. You can check it out in the OSI model with this application. Presentation session, transport network, data link, and then physical. Okay. So using this model only, we are transferring the data. Application, presentation session, transport. I will let you know this one. If you are using the OSI model, what is the benefit? Reduce the complexity, standardize the interfaces, facilitates the modeling, ensure the interoperability technology. Everybody are in the world, everybody are following the same technology. Okay. Using this only, we are transferring the data. So we will see the one by one here. What is meant by the physical layer? Take care of the binary transmission, so voice, connectors, voltage, data links. Data link layer will be taking care of your provide the connectivity and the path selection to host. Here the physical address will be connected. So what address will be here. It will take care of no error correction, mistake for the network layer will be taking care of your provides a reliable transfer for data across media. Physical address with IP address will be coming on the data link. Yes, network layer. If it is a transport layer, end-to-end connection. Okay. Here the data transport reliability will be ensured mainly during the transport layer. Okay. Here only the establishment will be happening. And then after once the establishment is happening, it will maintain. And then after that it will determine how to terminate, where to terminate. Okay, here only the virtual circuit will be happening between the two devices. Fault detection and the recovery information flow model here is started. Session is nothing but you are opening the multiple sessions on your window. One browser you are opening, and parallelly you are opening another one browser. that session will be taking care of this layer. Okay. And then presentation is nothing but you ensure data is readable by receiving systems. Let's say the other end people are not able to read your data, means immediately the error will be coming using the presentation layer. Application layer is nothing but you are seeing, correct? Now I am presenting, right? That you are seeing, no? That's called the application. That application only will be going through the presentation session, transport, network, data link layer, and PCB layer. How it is going using the header? It will split it. It will split and then send across the internet. Okay. And this is the way it is going. Let's say the source and destination, peer-to-peer communication is happening between the destination and source. And then here is a host of PCB. Let's say I am sitting in Bangalore and you are sitting in your college. Okay. How the data is transferring here? This is example next. Let's say I am a host A and you are a host B. I am sharing my presentation. Okay. This is the application. Google Meet. Correct. I am presenting many things that will be converted into, it will pack in the packet. Okay. Put it in the session. Then it will be sending into the transport, that is a PCB transport layer. And then via the network layer is nothing but it will reach your router and switches nearby. So after that data link layer, that is switches. So finally it will take care of the physical media, that is the zeros and ones. So this is model. Yeah. Now you see that. This encapsulation is happening here. Let's say data is application presentation session, all of the data that will be encapsulated in the transport layer. After that it is going to network. Then finally it will set the frame header. Okay, once the frame address forming, then it will convert into zeros and ones. And finally it will transfer that by program switches. Okay. So this is an example. Data at each layer. Let's say this person is sending an email. While sending the email, how the data is that your packet is split. This is the way it is split. Email, something about data, and you can call it up with the packet. Okay. And then in that network header, it comes inside. Whatever the email, on top of the email, that is called data, the left and right hand side header will be formed. Correct? That header is called the packet, entire packet. Frame header, network header, the data, frame header, then enter into your router. The router will be reaching the internet. So this is the way your data is transferring. Whatever the application are accessing the network, accessing the data, everything is comes from like this. Okay. This is a hierarchy network design. Maybe this is an important one. Maybe I hope you are understanding this. This is kind of how you are sending the data. Okay. Every data is added the frame. Okay. That frame will be converted into zeros and ones. That zeros and ones will be sending on the internet. This is a very basic network terms. If you have any doubt, let me know. Okay. How the data is transferred, this is an essential one. Okay. This is a hierarchy network design. Okay. If you take in the world, this is a hierarchy design. Okay. We are sitting in home or office. That is connected with switches. That switch is connected with that nearby routers. That router is connected with the layer of the core layer. That core layer is connected with the higher router. The higher router is connected with the internet. This is where we are exchanging the data. But we are not aware that what is happening behind that. We may see the data, but how the data is going and flowing, this is a knowledge. So this model we call this hierarchy network design. You can think about this core layer, distribution layer, and access layer. So everybody have accessing, so that is the access layer. Okay. your access layer will be distributed to core layer will be distributed to. So this is a way that your data is traveling. Okay, any doubt let me know. And as of now we have seen what is meant by data, what do we need to exchange, and exactly how that your packet or data is controlled, and what is the bandwidth, correct, and exactly how data is managed by some other network devices. Right? So as of now I have explained this. We will see that how the use case is happening. Packet travels. How packet travels in network, you will see in a small video. In the video you can see it out. Let me open it.
The amazing journey.
You are able to see my desktop, right? Friends, you are able to see?
No sir, no sir.
You are seeing now?
You have data packets from a data center to your device.
Sir, no sir, no sir, it's not coming.
It's not coming. Let me share my screen.
Sir, go to your Chrome tab and you can open it, sir.
Okay. You are able to see?
No sir, it's not coming. It's not coming.
Not coming.
Yes sir.
Yes, sir. More also. So, present it. Let me share again. I am presenting only.
On the internet, this data flow is governed to make the most efficient transfer of the data. It is apparent from this animation that this governing of the data from the source to the destination through such a complicated network is not an easy task. This whole process of the efficient flow of data from the source to its destination is known as routing. Let's try to understand routing through an analogy. Imagine a scenario where you are trying to reach your home from your office.
Have you thought about learning data science? You know, you should take this online data science course on Udemy. It's taught by an expert instructor.
Sunil sir, video is not coming, sir. Just the audio is coming.
Okay. Audio only coming. Okay.
Yes, sir.
Presenting only. Maybe some browser issue. Let me open another browser.
Yes, sir.
You are seeing this browser, that Google Chrome.
No, sir.
Okay.
No, no.
One second. Okay, stop share. Let me. Okay. Video. Firefox cannot allow permanent access on your screen. Okay.
Better you can copy that YouTube video in the chat box, sir. Paste it in the chat box. I can able to share. I think.
Yeah, yes, yeah, that also good actually. Which name is that? It's information technology.
Yes, sir. Yes, sir.
It's okay, everyone.
Yes, sir.
Yeah, you can have it. You can share.
Yeah.
So here we will see how the data is transferred. Sir, you are sharing that?
Yes, sir. I am sharing, sir.
Yeah, please.
The amazing security of data packets from a data center to your device forms the backbone of the internet. This data flow is governed to make the most efficient transfer of the data. It is apparent from this animation that this governing of the data from the source to the destination through such a complicated network is not an easy task. This whole process of the efficient flow of data from its source to its destination is known as routing. Let's try to understand routing through an analogy. Imagine a scenario where you are trying to reach your home from your office. The roads are full of traffic. In this scenario, we look up the road and traffic conditions on Google Maps. Based on the traffic situation and the road conditions, you take the easiest path to reach your home. Similarly, in routing, the decisions regarding the movements of packets are taken based on the state of network, and a device called a router makes these logical data decisions. The main purpose of having a router set up is to find the most efficient path through which the packets can be transferred from source to destination. Using very sophisticated algorithms, the router makes the decision as to which router or device the current packet has to be sent via. This procedure is repeated until the packet finally arrives at the destination. Routing can be divided into two categories, static and dynamic. In static routing, all the routes are set in a router manually. Thus, if there is any change in the network, there will not be any change in the route, unless someone manually corrects it. In dynamic routing, routes are set by the software according to the current state of the network. Network changes, such as link failures, traffic changes, and cost changes, will be updated at every discrete time step, and based on this information, new routes will be decided at each time step. Dynamic routing is preferred over static routing because the routers update themselves according to any changes in the network. Let's learn about one of the most popular dynamic routing algorithms, the link state algorithm. The link state algorithm has two parts, reliable flooding and Dijkstra's shortest path algorithm. First, let us understand the Dijkstra's shortest path algorithm, an algorithm developed by the famous Dutch computer scientist Edgar W. Dijkstra in the year 1956. Consider this network. Here the costs between each node are marked. The challenge is to find out the shortest path from one node to another. The Dijkstra algorithm produces a table as it does, and using that we can determine the shortest path in the network. This table is generated for the vertex A, and using this table, you can predict the shortest path to any other point. If you want the shortest path to point I, just check the previous vertex. From this vertex, check its previous vertex, and on until you reach point A. This table is generated using an iterative method, with the initial values of the shortest distance as infinity. Due to a shortage of time, we are just animating the procedure used to generate this algorithm. After the end of the iteration, we get the routing table, the output. Now we look at the first part in a link state algorithm, reliable flooding. You might have noted that to perfectly execute Dijkstra's algorithm, each router should have the information of the entire topology. This is the first step in link state routing. The neighborhood information of a router is known as its link state. This information can be the IP address of the neighboring router, cost of the neighboring links, health of the links, etc. The small packets that contain this neighbor information are known as link state packets. As mentioned in the name, we should accurately flood each router with the link states of all the other routers in the topology. This is very similar to how gossip in a classroom spreads like wildfire from one student to another, until everyone knows it. In a network, initially each router knows its own link state. For this small network, A passes its link state packet to its neighbors, B passes the packet to its neighbors, and so on. In this way, all the nodes will have the complete link state information of the topology. With this packet information, all nodes create or update a routing table and apply a Dijkstra shortest path algorithm to send the packet. However, flooding is not so simple. Consider a scenario where three nodes, A, B, and C, are interconnected. Node A sends link state information to B and C. Similarly, C sends the information to B, and B sends information to C again, and the process continues in a loop. This issue is known as looping. So, in an ideal scenario, you would want the node to receive this information only once. So, how do you overcome the looping problem? Each packet is assigned a unique ID. When B receives this packet with its unique ID from A and C, it does not send it to C. After the flooding operation, each node independently runs Dijkstra's shortest path algorithm to determine the shortest path from itself to other nodes in the network. The algorithm we saw is implemented in a network with the help of protocols. Applying the flooding operation to the entire global network is an almost impossible task. The protocol of the link state routing algorithm is known as OSPF. In OSPF, the complete network is divided into several local areas. A backbone area is also created, which shares at least one router from the local areas. This way, a few border routers are created. You can see how the local areas are connected to the backbone area via these border routers. In OSPF, the flooding operation happens within a local area, not globally. If the packets of a local area need to travel to another local area, they have to go through the backbone area. This is clearly illustrated in this animation. If the data packets have to flow from Area 2 to Area 3, they have to pass through the backbone area, not directly. This type of structure reduces the complexity of the operation by reducing the size of the routing table and also helps in the scalability of the network. We hope this video has given you a good overview about the routing operation. Thank you.
Hi friends, I hope you got that maximum of the information on how the data is transferred. And
Do you want to start your own business? With these
we have
theories,
seen the data, how the data is transferred
you
from
don't have to
area to
learn
one
what
area.
you're doing right. Doesn't
And
matter.
what kind of devices they are using to transfer the data. Okay. You may understand about that internet also, how the internet. This is actually, if you understand these things, you may understood about that internet also. Okay. So this is a way we can transfer the data. Okay. Let me share my screen now. Cannot share my screen. You are seeing my screen?
No sir, no sir.
Okay. Let's see, messages coming. Okay. So let me log out and then log in for the Firefox.
Yes sir. So students, if you have any doubts, you can ask to sir. Okay, sir will come within 5 minutes. There is some technical problem in his laptop. If you have any doubts, you can ask to sir.
Sir, that core VPN processor.
இன்னொரு சார் வரட்டும் ஒரு கேட்கலாம். ஸோ வாட் அபவுட் 43 மெம்பர்ஸ் தான் இருக்கீங்க, ஏன் லெஃப்ட் ஆகிட்டே இருக்கீங்க எல்லாருமே? உங்களுக்கான வெபினார் தானே நம்ம அரேஞ்ச் பண்ணிட்டு இருக்கோம், யூடியூப் லைவ்ல ஓடிட்டு இருக்கு. எத்தனை பேர் அதை பார்க்குறீங்கன்னு எனக்கு தெரியல. நம்ம டிபார்ட்மெண்ட்டை நம்ம அடுத்த லெவல் கொண்டு போகிறதுக்கு தானே we are planning. Voice not coming, sir.
Can you hear me?
Yeah, yes, sir. Yes, sir.
Now you are able to see.
Yeah, yes, sir. Yeah, yes, sir. Sir, you can proceed.
So, so as of now, we have seen that how the data is transferred, how the data is connected with that devices, okay, how the internet is connected, what kind of media we have used, what is the bandwidth. So everything we have seen, okay. And do you have any question here before going to IoT? Yeah.
Core browser, VPN processor.
Yeah, that we will see. We will see that after getting the time also for that, because we need to cover the emerging technology for IoT. Okay. Okay. We will cover the IoT first. Okay, that is a kind of emerging technology for the current system.
Sure, sir.
Then we will see that. Anything apart from this session, you have anything there? Apart from your doubt, anything doubt on networking devices, how the data is transferred?
Yes, sir.
You are clear, right? Okay. You understood the voice relay and all, right?
Yes, sir.
Okay. So we will go to the IoT. Okay. So this is emerging technology. Okay. Maybe you will be working after a year, also after 10 years or 50 years, or it will be there always. This is emerging technology one. Okay. So any idea what is IoT? Anyone? What is meant by IoT? Why do you need IoT?
Sir, some machines are connected to IoT, sir.
Okay. Come on.
Just devices like Arduino, these things are all programmed and used for IoT purposes.
Okay. Suppose what will happen if I am not connecting with IoT?
Through IoT, we can get accurate result and fast in time interval. We will get the output, sir.
Okay.
Or else we want to go to the machine and see what will be the output. These things and all we want to study, sir. And also, if in case of any issue in the machine, the IoT device will assure us, sir. It will send a message that the device is crossed over 40 degrees Celsius. That things it will through IoT get that messages and all, sir.
Okay.
So
Actually, your answer is okay. What is your good name?
Dhanush Puri, sir.
Ganesh Puri. Okay. See, the thing is, let's say, so what and all is emerging technology in our computer science society? What is emerging technology? Did you see somewhere else? IoT is one of the emerging technology. What else? Suppose, let's say, if you are knowing about the emerging technology, so you will be getting a job. Right? So, what kind of technologies are there?
Machine learning.
Machine learning. Okay. Data science.
These things are all, sir. AI, artificial intelligence.
Okay.
These things are all come under this category, sir.
Okay. Next. Did you see the data analyticals? Data science.
Yeah, sir, but not so accurate.
Okay. Data science. See, emerging technologies are nothing but we have to work now. There is a emerging to finish the work. Right? Let's say artificial AI. AI is there now. It has been there past 15-20 years. Correct? What do you need suddenly the AI? Any idea? Anyway, I will let you know that also. So emerging technology is nothing but the technology is growing now. Right? Let's say IoT, it's growing. So around in the world, 40 billion devices are connected each other. How much? 40 billion. So those devices need to be smarter. Okay. To enable those devices, we need an IoT platform. Okay. Let's say in our home we have a Fuji TV and other AC doors. So that are all some non-technical devices. So how to